Okay, we're at work on the casting for the steam chest now, and checking the drawings, it shows that this boss on the end of the casting here, which is going to become the gland for the piston rod, is offset. So it's 3/16 from the machine face on one side, and what's that, 4/16, quarter of an inch from the other face here. Did I tell you how much I hate imperial measurements? So looking at the casting, one side of the casting is almost touching the oval shaped flange. So that looks like the one that I'm just going to have to very lightly clean up just to get a clean surface, and then I'll be setting my finish measurement of 7/16 from that face. So I've got a pair of parallels set up in the device, and I'm just going to rest that on the parallel. I've got some copper here just to take up any difference in the dimensions of the casting. I'll just knock that down. Okay, well, I've finished machining that. I took just the bare minimum off that surface there, and I've still managed to take a bit off that flange. I'll clean that up with the file and you won't notice it. There are a few little imperfections in the surface, but this is going to have a gasket and it's going to be clamped down, so it's going to be fine. What I'll do now is turn that over and we'll machine the other side. Okay, 11.14. So I'm going to leave it there, and then that'll just give me something to clean up, just to remove the machining marks. You might be wondering why I didn't fully clean that up. This casting, once again, has almost no machining allowance on it. This is supposed to finish at 1 3/8", and I had literally like 5 thou clearance on each side, so I haven't completely machined that off there. I'll just check the dimension. According to my caliper, it's 0.3 over, so I can take a little bit more off that. That's better. So that should be close now, and I'll give that a draw file to finish. The rest of this now I'm going to do on the metal lathe, and I'm not going to bother about cleaning up the inside. I know this looks really unconventional, but believe me, it works. What I have to do here is machine this section of the valve chest, and this is where the valve rod is going to extend up into this little spigot. It's off center from the width of the steam chest, or the thickness of the steam chest. I've marked it out on a surface plate. No, I haven't. I don't own a surface plate. I marked it out on the table of my circular saw, and I put a center punch mark there indicating where that center should be. So what I have to do is to get that center punch mark running true, and then I'll machine this little section of the spigot. It's going to have a domed end on it, and I'll remove the center punch mark when I do that. So what I've got is, I've got my tailstock center, I've got my job in the 4-jaw chuck, and I've got this center which is just free to rotate. And all you need to do is to rotate your chuck, just make a note of the reading and adjust it accordingly as if you're doing circular work. And it's surprising how quick you can get this done. So just look for the spot where it's furthest away, loosen that jaw. If A-bomb was here, you'd have it done in no time. Alright, that's probably close enough, but I'll get it right. So I know Keith's watching. There you go, that's good. Alright, so what I can do now is go ahead and machine that feature, clean off the end of the valve chest, just until I got a flat surface there, and I'll dome that end. I just realised I want to put a radius in that corner there, so I'm going to swap out this tool for one with a bit of nose radius on it. Okay, that's good, and this needs to have a radius on it, and I've got a radius turning tool. I wonder if I should put that on there. Yep, Keith will be watching. He will expect me to do this geometrically perfect, so let's do it. Well, this is my radius turning tool. It's a DIY job. I cut out these sections here on my CNC mill, all three of them, and I've already set the tool tip, and I just use a depth gauge off these two end faces here and work out the dimension that I need. So I'll get that set up. I did have to move the job out of the chuck a bit to get clearance for this, and all you need to do is turn the tool 90 degrees, touch the tool tip against the end of the stock, and basically lock your saddle at that point, and then your feed in is done with the cross slide. Alright, it's not bad. Okay, well, the other end of this steam chest has to have a 9/32 drill and a 1/8 drill all the way through, and a gland will be fitted into this later to compress the packing and make this joint steam tight. So I've centered this one the same way as I did the other end. Typically, the one I did on camera took about 10 moves to get right, and this one I did in 3. I know you don't believe me, that's just how it worked. There's no thread in this, it's actually compressed by 2 studs, which makes it a bit easier. The only thing I'm worried about is that the drawings show that at the other end there's a 3/32 drill bit that has to go all the way through into that spigot that we've already machined. Now the chances of that drill bit staying true are just about nil. So I don't know how that's going to work. If it wanders off at all, the valve rod's going to jam or it's going to bend. And there's no repair except maybe for machining off that spigot altogether and somehow fitting a sort of a dummy spigot, which would work. But I want to try and get it right. I'm just going to take it very slowly. I have filed the other end of the casting where the drill bit's going to touch, just hopefully to stop it wandering off. And what I'll do is I'll take the 1/8 drill bit through until it's drilling at the other end, and it being a little bit stiffer, it's going to hold better. The drawing shows 3/32, which is a very narrow drill to go that far. What I've done here is I've drilled that number 31, which is undersized for 1/8 of an inch, and I'll run a 1/8 reamer through that afterwards. But what I want to try to do now is get the other end of this steam chest drilled. I'm going to try and run this drill bit all the way up to the other end and at least get it started. And hopefully it's not going to twist off true. Well, I can't see anything, but I can feel it cutting, so I'll run the 1/8 inch reamer through, and then we'll try. I can see it's made a dimple at the other end. We'll try running the 3/32. Okay, So I'm going to swap out now for a 3/32 drill bit, see if I can drill the other end. I'm not sure if I've got a drill bit long enough though. And what I can do now is extend that drill bit out so I've got as much reach as possible, and I'll set the drill bit at the beginning of the hole and read off 1/2 inch on my tailstock barrel so I've gone the right distance. Okay, so I've reset my drill bit and it's only just gripping on the very end of the drill shank, so it's not the best situation at all, but because I've pre-drilled the other end, once the drill bit gets guided into the hole, should be okay. So I've got my tailstock barrel set to 0. I've got 1/2 inch of travel, and I think I've just barely got 1/2 inch on extra on the drill bit. Okay, that seemed to go okay. All I need to do now is open out this end of the gland to the dimensions shown on the drawing, which I think is 9/32. I think I'm going to leave that there. I'll leave that with that number K drill. It's probably drilled oversized, so I can make the gland to suit. Okay, well that takes care of most of the parts of the steam chest. Now you can see here that the cast boss that was left after I've drilled and reamed and done everything else is off centre, and there's nothing you can do about that. That's just the way the castings were done. What I might do is put this on the CNC mill and machine an accurate elliptical shape or similar to that shape around that hole, and then I'll do all of the glands at the same time so they'll all match up, and then I can drill the fixing holes for the studs as well. This is the bronze casting that was supplied to form the gland that fits into the hole that I've already drilled in the end of the valve chest, and this will have some packing in here later on. It will be compressed to form a steam tight seal. So what I need to do is to machine that to fit that hole, face that off, drill through and ream 1/8 of an inch. Well, shoot. Okay, what happened there was I ran the edge of the tool bit, into that flange, and disaster. Okay, reset, try again. I'm going to use a different tool. I'm going to be a little bit more careful. I might even face that first. That's it, that's what we're looking for. So I'm just going to face that again and I'll clean up the rest of that corner, and then we'll drill and ream. Okay, so the last thing you would have seen me do there was to chamfer the inside of that hole to 120 degrees. I think that's in order to get the packing to slide down that conical surface there and pack around the valve rod. Okay, that's interesting. It looks like the countersink has actually enlarged that diameter slightly. It's fitting. It's a little on the tight side, but that's okay. Yep, that's good. So what we can do now is to machine both the gland and the end of the valve chest to the correct shape, and I've already drawn that up in my CAD program, indicated the hole centers so I can drill through for the studs in both parts. Alrighty, the valve chest cover is a rough casting all over. This is going to be the outside face of the casting when it's done, and I've seen some of these Stuart engines have the letter S cast into that recess there. This one doesn't. I have to be able to get at least one flat surface on this, and the obvious one is the mating surface that goes against the valve chest itself. And it's a little bit too thin to grip in a vise and a milling machine. There's sort of no easy way to hold it down to a milling machine table, so I'm just going to do this in the lathe. I've got my 4-jaw set up here, and I'm just going to lightly grip this, and then I'm going to use my tailstock Jacob's chuck to press in against that and try to align it. This method seems to work quite well, and this is just a cast face, so we don't have anything really accurate to work off. So I'm just going to squeeze that, push it back into the jaws, and that should align it enough so that we can clean it up with a single point tool and not remove a lot of material. I'm going to leave the back face as cast, so I reckon that looks nice. And that just means cleaning up the 4 edges to match the dimensions of the valve chest when we're done. That's pretty good. It's got nearly all of that. So I'm just going to clean it up, keep the revs relatively low. Oh mate, how good is that? So once again, the amount of machining allowance on these castings is tiny. I reckon Keith kept these for so long they've shrunk. There's enough there to clean up though, so we're going to do all 4 edges of the steam chest cover, and then it's all about drilling. The edges of this steam chest cover are a little bit oversized. I'm just going to put this in the vise. It's resting on a parallel, and I'm just going to use a piece of brass packing here. And you're probably thinking this is a bit overkill for a little tiny thing like this, and you're probably also thinking that if I dig the tool in it's going to snap that off. But I've arranged it so that the path of the inserts is going to be more or less along that edge. We'll see how it goes. Well, that's one done. You can see how little I've got to clean off on that other side. It's really only just going to get below the cast skin. You might be wondering why I've shifted over to the lathe to do these 2 ends, the unmachined ends of the cover. I mean, I've got a nice shiny milling machine over there. Why wouldn't I use that? Simple answer is that the 4-jaw chuck will automatically square the stock for the remaining cut, whereas if I was to use the mill, I'd have to use all sorts of trickery to get the previously machined edges square. So I'm just using a bit of brass stock on the unmachined side. The other jaw will push that up tight. And it's such a simple cut, it's hardly worth doing it any other way. So I'll clean this one up. Okay, so one end to go. And I think I'm just going to scribe this. It doesn't have to be that precise. To machine the other end of the valve chest cover, I've just scribed a line at 1 9/16 of an inch from the previously machined end, and I'll just trim that off. Okay, so we'll just deburr that part, and it's done apart from the drilling. Okay, here you can see the bronze casting which forms the gland for the valve rod. So what I've done is I've used a centre finder with the ball end on it, and I just run the spindle and I've just run my vise in X and Y until I was satisfied that that centre finder was lined up with the hole. So that's going to become the origin for my tool path. The tool path is an elliptical shape. I've done a roughing cut and then a finishing cut, and I've set my depth to 3.3 millimeters, which is a little bit more than the thickness of that casting. So it's got to be a bit careful I don't run into the nut on the collet chuck. So I'm going to be using a 4mm 2-flute slot drill, and we'll swap that out now and run that tool path, see how we go. Okay, so here goes. I'm just going to run this cutter dry, and I've set my origin point, and I'm going to run it. I always do these things like manual step first, or single step, just so I can stop things if it looks like it's doing anything stupid. So here we go. Okay, it's left a little bit of a burr there, but I'm pretty sure that'll come off. So what I'm going to do now is to drill the 2 stud holes in this, and I've got my tool path set out for that. A lot of you are going to be looking at my feed rates and cutting speeds and so on and being all judgmental. For me, time is not money. I'm quite happy to let that go at 150 millimeters a minute, and my step down was only 0.5, I think, per pass, and I was using a spiral tool path pattern. And you know, yes, you could probably do that in a much more aggressive feed rate with a more aggressive step down, or even just, you know, full depth machining. But I'm always concerned that, you know, that collet's gripping on bronze. It's not the most rigid of setups. My machine's certainly not a rigid machine, and if that were to let go and the cutter dig in, it would just spin that and break the cutter or destroy the part. So I don't care that it takes 5 times longer than it would take for a professional CNC machinist. I've got the time. It's not a big deal for me. So I'll go ahead and drill this now, and then we're done with that part. Okay, so there's the flange. Just got to remove that little bit of a burr from it. But what I need to do now is recreate that exact same profile in the cast iron. With the steam chest covering the vise now, and I've aligned that with the parallel down the side of the vise, so it is truly vertical. And I've got to drill the matching holes for the gland into the end of the steam chest cover. So I'm going to use the same G-code that I had set up to drill the flange, and we'll do that now. Okay, so I'll swap out for a tapping drill. Those threads aren't full depth, I just started them and I'll finish them later by hand so I get a better feel for what's going on. So what I need to do now is to run that same tool path that I used on the gland, and it's going to trim up the outside of where the excess stock is, and it's also going to flatten this end of the steam chest cover to the correct length. Well, that was painfully slow. I reckon I could have chewed that metal off my teeth quicker than that happened, but got the job done. And as I predicted, it didn't really clean up on the back, but it did at the bottom. So what I can do is I'm going to fill that with some liquid metal and then blend it and then powder coat over it later. It'll be fine. So there's the gland with the studs through it, so those studs will screw in, and then later on when we put the packing in there, that'll compress the packing and give us a steam tight joint. So it looks beautiful on that side. Let's hope that's the one that everybody sees. The next job on the cylinder is to drill 6 holes in the steam chest cover, and there are 2 on the short end, 1 in the middle of the long end on either side, and 2 on this end. And what I've done is I've drawn that in Corel Draw. I've exported that to Kanban, and I've worked out a drilling program to do the 6 holes. I'm going to drill the cover, and I'll drill the tapping size for whatever threads I need in the cylinder, and then I'll use the cover as a drill jig for the steam chest and the cylinder. So it seems like a roundabout way of doing it, but trust me, it works. So I'm going to set up for probing this edge here and this edge of the vise, because my origin on my CAD program is here, and the same in the cam. So we'll get that point zeroed in and then we'll do our drilling. If you're wondering what the noise is, that's the rain. And by the way, this is the pendant that I'm using. It's an iMac 3, and it works really well for me. It allows me to do all my probing, all my jogging, etc., and I find it really accurate and easy to use. Alright, so just going to probe this edge. Okay, 0x. And I'm going to probe this back edge of the vise and use that as my reference for Y. Okay, let's stop there, so I'll 0Y. And using a manual data input now, I'm going to offset 3mm Y plus and 3mm X plus, and that will put me right over the corner of the steam chest cover. So we're going to go G0 X3 Y3. Okay, so that's got me right on that corner, and we're going to 0 X and Y again. Cool. Okay, going to swap out, get a center drill in there now, and we'll do all the drilling. Okay. Alright, so I'm going to drill right through now, and then I'm going to spot through those same locations into the steam chest, drill right through those, and then I'll use the cover once again to spot through into the cylinder port face and then drill and tap, and then I can open out all of these holes the correct size for the studs. Okay, you'll need to excuse the noise. We got thunderstorms outside and we got rain on the roof, so I'm just going to talk over it. This is the setup I'm using to drill the cylinder to match the stud holes in the steam chest cover. I know it looks weird, but I think it's going to work. So what I've done is I've clamped the steam chest cover onto the cylinder with a toolmaker's clamp. I've got a piece of brass inside so I don't damage the bore of the cylinder. I've gone around and I've checked the fit of the steam chest cover on that cylinder, and I've got it flush on this end. I've got it centralised on the width of the cylinder face, and I've clamped everything down really tight. I've checked this is level in relation to the vise, and I've locked my drilling machine table off. So I'm going to go through and spot through each of those 6 holes into the cylinder port face, and this is the tapping size for a 7BA stud, which is going to be used to hold everything together. Now I'm doing the cylinder first, and I'll do the steam chest later, and you'll see why in a minute. It was a little bit more problematic to hold. So I'm just going to go ahead and spot this through. Okay, now without removing the cylinder from the vise, I'm going to drill the correct depth as shown in the drawings. And it's actually quite a shallow hole. I think it's only 1/8 of an inch. And I think the reason for that is that we've got to be careful we don't drill into the exhaust port, or the hole for the exhaust port. So this is where the exhaust port is going to come out through the side of the cylinder, and obviously there's a stud directly over the top of that, so we've got to be careful we don't go into that space. The stud was sealed properly, it shouldn't matter too much, but I want to get it right. So I've just got that lightly clamped with the toolmaker's clamp there now, and I'm just going to tap this down. Just to make sure everything is aligned correctly. Alright, just using the old fingertip comparator. Alright, I reckon that's good. So what I'll do now is I'm going to drill just say 1 hole here, maybe 2, and I'll get some studs and nuts in there, and then I'll do a couple more, but the clamp sort of gets in the way and stops you doing all of them. Well, with all of the drilling and most of the tapping now complete in that cylinder port face, I can now insert the studs and partially assemble the steam chest. If you're wondering why this particular hole is bigger than all of the others, you will have to watch the sad but true story about how I broke a 7BA tap off in that hole. Now clearly I've removed the broken portion of the tap, and it was a bit of a blow to get through all of the machining to this stage and then lose concentration for just a second and snap that tap off. The reason why this hole is not complete is because I'm waiting on the replacement tap. So what I can do now is I can insert the studs into these very shallow holes, and that was part of the reason why I broke the tap off. And I can assemble the steam chest. And the steam chest cover. So in the next episode we'll take a look at machining the cylinder bottom cover in this case and the top cover to go at this end, and we'll also have a look at machining the piston and its associated piston rod. So let's wind this episode up here, and thanks for watching.